So we have our initial Lidar data as a series of images captured by the camera on the Raspberry Pi, and now we need to take those images and convert them into a 3D point cloud. And in order to do that, we are going to use the following code called datageneration.py. Now what this does is take all the images and then it runs them through an HSV mask to determine where the laser line is, as determined by the parameters here, which we figured out using the color picker script, and of course the values of rho and RPC, which are the calibration values for our LiDAR sensor. Now it processes each image in turn and figures out where all the individual data points are, plots them into a file called scan.txt in this case, or scana.txt, and then outputs them. Now there's a little bit of extra voodoo magic to be done with this test data set because initially, for some reason, the images failed to generate a strong presence of the laser. And so, initially, none of the data showed up. So in order to fix that problem, what we have here is a set of code I've written which takes each individual image and then runs it through Dr. Mitchell's amplification process, whereby each pixel is analyzed and every pixel that has red in it is increased. The red content is increased, so the laser line essentially pops in the image. And this does that process for every image in a specific folder. Now, once we process all those now modified images into a point cloud, we get a final cloud, which I'm not going to show in Python with OpenCV because it takes a while to generate and is not a great graph. So we'll switch over to MATLAB and show you that point cloud, which is in this case of a chair, which you can see in the lower part of the image. Unfortunately, the cushions did not show up, but the legs of the chair did, and a carton of goldfish placed on top of that. Now the carton is the more interesting of the two objects in this image because not only can you see the rectangular part of the carton here, which if we rotate the image you can see is actually a rectangle, but you also, interestingly, get to see the slant, which you can see right here, of the 45-degree angled top of that carton.